although I might condense that part of the slides anyways in a few minutes. So this first line here, we have a notion in the current service called a model, which is essentially a collection of versions. It allows you to, and we'll see how this, in the context of training new models every day, how it allows you to keep various versions and switch between them. Like, I'm serving yesterday's model, and I now need to serve today's model. But for the time being, think of it as a container. We create this model. If I do it again, I'll get an error, because they have to be unique, so I'm not going to run it. Now this mess that is curl will not be there in about a week or two. We just got the command line tool updated to accept framework as a command, and it wasn't there. So it's essentially, it's very similar to the models create command, but it's versions create. So we're saying create a version of this model. And since I bumped up the version to v4, when I run this, it's actually going to the cloud. And you can imagine, because it's doing all the things I talked about, load balancing, web servers, blah, 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 it does take a little while. But ours is actually very fast. It takes about, I think the median time is 90 seconds. Your very first model may have a little bit more in it time and be more on the order of 5 minutes, but it takes about a minute and a half. So while we're doing that, let's switch back to the slide deck. Now I know we have to do a context switch. For those that are engineers, software engineers, you'll understand that reference. But the question is, why is production such a long fold? Remember, that was one of the pain points that we're addressing in this talk, that it's hard to get models to production. I wanted to open that question up to you guys. What are some of the reasons that it takes so long for models to get into production in your experience? Getting the data. Well, what about once you have the model, though? So you got the data, you train the model. All you really want is the show impact, right? To get better performance review scores or something like that. Validation? Well, that's a good point, actually. Yeah. And I don't talk too much. I hint at that on one of the slides, but you're not going to push something to production that's junky, right? Bring down your system. Any other reasons?
Performance evaluation.
Performance evaluation, absolutely.
These are the other thing you want to be sure that you can roll back if something goes wrong.
Yeah.
So you have to prepare for that.
Yeah, you got to be able to do a safe rollback. Very good. Back here?
Managing the infrastructure.
Yeah. How many of you like to do that? How many of you consider your favorite thing to do is to manage infrastructure? And that's why I have a job here, right? Doing this exactly. I may be the only one in the room. Here's a few other things. You guys said some really great things. I didn't even think very hard about this, and these are the ones that came off the tip of my tongue or fingers. You need to get approvals. You need to do capacity planning. Some people, I actually had a conversation, I can't recall right now who it is, but you have to convert your model from one format to another format and then do validation on it, that type of thing. There's some technical challenges. Somebody mentioned that just creating a serving system is a very complex stack. You have your load balancing, you have your web server, you have authentication, you have authorization, oftentimes you have a cache, you have logging agents, you have monitoring agents. They all have to work together. If you put all these, one thing is to get all those up, another thing is to keep all of them up, right? Because if any one of those pieces goes down, it's your pager that goes off, if you're the production engineer, right? And you probably don't want that to happen, and certainly those of you that are data scientists, even if you're capable of doing this, that's probably the last thing on earth you'd want to do. Otherwise, you would be a production engineer and not a data scientist. So here's what CloudML Engine Prediction offers. It's click to deploy. It has auto scaling, horizontal auto scaling. So as you send up more traffic, it scales up. You send up less traffic, it scales down. And it's serverless, so it scales all the way down to 0, which is really fantastic when you're, for, say, you're a startup and your traffic patterns are very sparse at the beginning phases, right? You get some traffic and you're happy. It scales down really low and you're not so happy. Or very spiky traffic. We scale up very quickly. Our servers are able to scale up very world-class, really. We give you encryption, authentication, authorization, logging, monitoring. You can organize your models with labels. You can do versioning rollouts and things of that nature. So let us go back here. Because it's a Jupyter notebook, you don't get the nice spinny indicator. I don't have a nice extension to do that. But we can go ahead and just start sending traffic to it. So you can see that this piece of code is really boils down to these 4 lines, which is essentially one line that I broke up because lots of lines, a really long line is hard to read, or 2 lines really. You create a connection to the service, and you call execute, and you pass it the data. This example, it's not clear from the way I've organized the Jupyter Notebook, but it's literally the same data structure we used for the local prediction. Okay, that's going to get translated obviously to JSON because we've set up a REST API to do that. And you can see if I'm lucky, in the previous run they were both the same. I'll keep my fingers crossed with the live demo, and I get a warning about credentials, but otherwise we get the same value. I'm comparing the local prediction pipeline.predict. Recall that I have an scikit-learn pipeline, and I'm then calling cloud prediction and grabbing that out of the cloud. Very fast, low latency response times. You can see that, well, it happened to still be up, but if it had scaled down to 0, that request would have taken a little bit longer to bring up the servers, but it's very fast. Okay, so let's move on to the next section of the talk. So that's prediction. Like I said, the premise was you have a model. We combined scikit-learn features like pipelines and XGBoost as the underlying model. You can use any of the models that scikit-learn has to offer, any of the transforms that scikit-learn has to offer. Essentially a click of a button, and we're working on a GUI, I think it's close to being implemented, where it's literally a click of the button, you point to the model, and you're off serving in production at production scale. And you don't wear the pager, I do. So let's talk a little bit about MLOps. This asterisk ops, if you will, is sort of a buzzword in the industry. You've got DevOps, you've got data ops, you've got SciOps, you got I don't know what other ops, right? So of course there's MLOps, because why not, right? What do we mean by that though? I like this diagram. If I hadn't have stolen it from a paper from some folks that work here at Google, I probably would have chosen a little different boxes, but I think it serves to illustrate the point very, very well about what MLOps are. If I can direct your attention to that teeny, 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 teeny box in the center of the screen, that's the ML code. That's the code that you guys write as part of your job to get a model running. All the other stuff is what it takes to serve, not just serve, but to train and use ML in a production scenario. Sure, if you're just fooling around like for a research paper and you gotta get a more accurate model than the last guy that published a paper in this domain, you don't need all this stuff. You can do it in a Jupyter Notebook. Go use Colab or Kaggle kernels or your favorite Jupyter Notebook and get it done. If you're gonna do something in production, there's a lot of work that goes into it. You guys are probably very familiar with the data collection phase, maybe configuration as well. Obviously feature extraction in a production system that has to be running, it's like a service that's running on a continual basis. We have your serving infrastructure, which we already went into slightly more details about how complex that can be. You've got to have resources, monitoring, blah, 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 blah. There's a lot that goes into serving in production. So what is, when you think of the term, define the term MLOps, when you define the term DevOps, it is bringing software development, it's merging software development processes with software operation, right? So I actually think that definition does not hold up for MLOps. Why? Because I feel like we should be taking the ops out of ML. So that our jobs in serving production systems is more like the small black box and less like everything around it. Let's let the infrastructure, let's let somebody else have the job, let's let somebody else carry the pager type of thing. And so that's really our goal. So let me give you an overview of what I think the steps should be for MLOps, with most of the ops taken out of the MLOps. The first step is to develop your model. I would hope that that would be 99% of your time. You spend the 3 weeks to get the best darn model you can out of your data, and then you're ready to use it in production. Of course, yeah, this is the nice GUI that I said that's not quite there yet, but it will be in a few weeks. You click a few buttons and you deploy it. You can go, and I forgot to do this, maybe if we have a chance, we can go back and look at it, but we have monitoring and logging for all those models that we just deployed. Single click and it's all there. So you're looking at it, you're looking at your latencies, and you say, oh wait, why is my latency so high? Okay? And then you say, oh, I get it. I didn't have enough cores, or I didn't have enough nodes to handle the spikes that we had. You make a few tweaks, you click a button, and you're off and going. So yeah, maybe there's, and ideally you don't even have to do this, but the reality is we're not quite there yet. So you have to do a little bit of tweaking. But you can even do it yourself. That's how easy it is. And that's how I think MLOps should be done. So why cloud? Now I don't know, I probably should have asked the question. I don't know how many of you, well, let's just do it. How many of you, your companies currently use the cloud for any of their ML? You have a few, but not many, right? And we find that to be true. I'm not here to sell you on cloud. It might sound like it, and I apologize if that's true. Obviously, that's what I do for a living. But let's just have an open conversation here. The cloud isn't necessarily for everybody. I had a few conversations offline with some people. But here's where it does shine. And if you fit these needs, you ought to consider it. We have world-class networking and infrastructure here at Google. We really pride ourselves in that. So you can count on lower latencies, faster startup times, and things than you get by rolling your own solutions. Elasticity and scaling, those are buzzwords as well. But if you think about it, if you purchase a cluster of computers to put in your own office or your own data center, you have a fixed cost. And if you use more than that, you're going to get really bad latencies when you're serving because you don't have enough capacity. If you use less than that, you're wasting money on servers that are sitting idle, or worse, using power. So in the cloud, you know, you're paying for what you use. You scale up, you pay for what you use. You scale down and you're not using any, you don't pay for anything. High availability, Google prides itself in this, and part of that's due to the next line, which is Google SREs. SRE means Site Reliability Engineer. You may have heard of this. Google hires the very best engineers that know how to run and maintain production systems. And they help design the system so that there are fewer outages to begin with. And when there are outages, it's their pager that goes off. And they know how to respond and quickly mitigate any problems that are there. And that's part of the reason why Google Cloud has high availability for its services, is because of these folks here. Speed of deployment. You saw in 90 seconds, we went from a model that I trained on my laptop to one that was serving at production grade. Okay? And then you'll probably see this line. Maybe I overemphasize this, but I really believe that the total cost of ownership and paying for what you use is a real benefit of the cloud. So what if you're not ready yet? There's many reasons why. Maybe these use cases doesn't fit your scenario. Maybe your company is really slow at adopting things like cloud or other technologies. Or maybe you guys are just onboarding, but you still have a transition time. I'd like to refer you to Kubeflow, which is built by our team, the Cloud AI platform. And what it is I like to call it the anaconda of ML. So it's a bunch of packages that bring you ML, make ML very easy to do on Kubernetes. So if you guys are already using Kubernetes or thinking about Kubernetes, where you can run it on your laptop with Minikube, where you can run it on your on-premise if you have like private cloud or on-prem servers. You can run it on the cloud. Amazon just released their Kubernetes. Microsoft does their Kubernetes, but obviously I want you to use Google's Kubernetes engine. And there's the hybrid case, where maybe you do have a data center and it's at capacity, but when it goes over capacity, you can spill over to the cloud. And of course, the Cloud ML engine that I'm focusing on more or less today, I'd like to think of Cloud ML engine as managed Kubeflow. If you don't want to manage the stuff yourself, you can pay for the managed service. All right, so I focused a lot on prediction, but the ML ops stuff is a lot more than just prediction, as we saw in the diagram. So now I want to talk a little bit about non-prediction cases. And there's a lot I can say, and I can tell you just as a teaser, expect a lot from Google in the coming months in a lot of really cool stuff, and that's all I can say. But when might you want to train in the cloud? These may seem obvious, but let's take a second to talk about them. In the cloud, you can get really large machine types. How many of you guys have 96 cores sitting under your desk? If you do, I want your machine. I can't remember what we cap out at, but I think it's somewhere like a terabyte of RAM. We have machines that have that much memory. And you know what I found? I actually had an intern do this last summer. I said, hey, go grab the Criteo data set, go get as much RAM as you need, get a VM with as much RAM as you need, and train it and see what happens. Took 3 hours to train. He needed a lot of RAM, hundreds of gigabytes, I think. Took 3 hours to train and he was done. He didn't have to go figure out how to do distributed training. He just had to pay for 3 hours of a server, a fairly reasonable price with that much RAM, shut it down when he was done, and he had a really great model because it was trained on all that data, right? Number of cores. Imagine you're doing hyperparameter sweep, grid search, or something like that, and you want to do it in parallel, but you don't want to set up a Spark cluster, or you don't want to maintain any of that. Go get a machine with 96 cores. You can run 96, well, it depends on how many cores each job's running, but you can do a lot of stuff in parallel with 96 cores. Of course, you don't want to go get a VM and do all your work on that, because you'd be paying for it the whole time. It's expensive. But this is what the cloud brings to you. I talked about distributed training. It is non-trivial. If anybody's had to set up XGBoost to do parallel training on Spark, you can do it. There's some sample code online to try and do it, but it's actually non-trivial. And we don't yet support XGBoost distributed training, but for TensorFlow It's very simple to do distributed training. If you're using TF Estimator, you literally have no code to change. You submit it to the cloud, and it scales up to the number of servers you tell it to scale up to. And hopefully one day we can bring something like that to XGBoost. We have a hyperparameter service called Hypertune, which is available for XGBoost and Scikit-learn models. And it gives you much better results than doing grid search or random search. It's state-of-the-art algorithm, so you'll get best-in-class performance there. And it's all in parallel. You know, so you don't have to wait over, you don't have to, so I talked to a researcher here at Google, and he says what he does is he plays around during the day on small data sets, gets things how he likes them, sends off a job at night, comes back in the morning and checks on how well his model did, keeps his fingers crossed that there was no errors halfway through, right? Anybody relate to that? I know that's what I did during my PhD too. Repeatability. So what I mean by this is, I think there's more examples, but the best example of this is with continuous training. So we're talking about training a click-through rate model where you get new logs and tons of them every single day, and every single day you're going to train another model, right? And so you're going to use the same code, and you're going to use it every single day, or actually, a lot of people train like every hour, so they're training very frequently. You're not going to want to go to your Jupyter notebook and hit a button at 4 p.m. every day to train another model, right? This is a repeatable process. It needs to be productionized. It needs to be robust. And so the cloud is really great for this. And in fact, if you're taking advantage of those large machines and those large cores, you know, it sends off the jobs, it uses all those things for a short period of time, it shuts it down, and you only pay for that time that you're doing it. So let's come back here to see what that might look like in the cloud. So there is a price to pay when you're switching from your local machine to the cloud. You do need to package up your code in a way that the service can understand, and there are multiple ways to do that. We'll be supporting containers, which is becoming an industry standard way to do it. For now, we use Python packages. So you just run this, you just run Python setup.py sdist. You see the second command then uploads it to a bucket in the cloud, and I think that's finished. And then I'll go ahead and hit enter. And then you can see right here, all I'm doing is saying submit a training job called CTR for click-through rate with its timestamp so it's unique. I'm saying that it's trainer.train. This packages is what we just uploaded. The runtime version tells us which version of. Now that's a little. I wish that it was more obvious that this was like Scikit-learn whatever version, but this does translate into Scikit-learn version. This is CloudML Engine's runtime version 1.8. We're going to do it in US Central. It's with this project and a few command line parameters. So just since I forgot to say this train.py is that exact code we saw at the beginning. The only thing is, like, you would probably take off that max sample lines that I had because my Pixelbook couldn't handle, and it took me, I won't admit how long it took me to figure out that's what was crashing on my notebook because it didn't tell me. And you know, you might change the max depth or the number of estimators to be what you would have in production. This is your actual production code. So you make a few tweaks, you send it off to the cloud. You can see that the job was queued. Again, we don't have a first-class integration, so we have to go over here to our list of jobs. And let's see, that one, you see the spinning thing means it's still spinning up the machines. This is training. Our prediction service actually spins up the machines very, very fast. The training takes a little bit longer. I think if it's a single machine job, it's usually around 1 or 2 minutes. So we can go to this job here, take a look at the logs. Nothing super interesting, just to show you that there's this integration here with the logs if I'm lucky enough to get it to come up. So you can see that all the outputs captured in the logs in case you need to go back and figure out something that's wrong or something that's right. And you can see that the job completed successfully. Okay, so that's how you send off a single job. But the use case that I was talking about is really about productionizing this and doing it on a daily basis. So there's how many of you are familiar with Airflow by chance? A couple of you are, probably the data engineers. I mentioned to somebody before we started, I hinted a little bit of pipeline here. So what Airflow is, and there's lots of orchestration systems, but it allows you to run, chain together various processes that you can then do on a repeated basis, in this case on a daily basis. And so you can see that right here. And I'll get into what this actually means, but you can see that every day for the last 2 weeks, this model has, that code that we just submitted to the service to run to train a model, has run on the previous 7 days worth of data, produced the model, and then push that model to serving. So let's go ahead and, you can see that in a graph view here. Very, very simple DAG. I did that for the sake of this demo. It just does training and create version, but you guys have already pointed out an obvious problem with that. If something went wrong during training and I pushed it to production, I'd be in a world of hurt. Could even get fired for that. So what you would normally do, and it's not too much, it's actually not that difficult, you can put another node in the graph that runs evaluation and another node in the graph that checks that the quality of that model is better than the previous, or the model that's currently serving before you push it, and then go ahead and push it to serving. But for simplicity's sake, I just trained and pushed. And you can look at the code to do that is actually very, very reasonable here. Again, you have the preliminary, which binary do I use, etc. These DAG args are just necessary for airflow to work, a little bit of overhead, copy and paste is what I like to think of it as. And then here's where you say, hey, with DAG, in other words, with my pipeline that I'm trying to define, you have this training op, which looks very close to the G-Cloud operation, but in Python code, says, hey, use this binary for training. And then you have the create version op, which again looks like the G-Cloud option for pushing a version. So with, I mean, I don't know how many lines of code that is, but the core of this is what? 20 lines of code maybe? And we've defined this pipeline that we're able to run in the cloud on a daily basis that pushes the models to production. Let's see if I have this. So you can see, here's the model CTR daily. Remember how I said models like a container for versions? And here are all the versions of that model that got pushed on a daily basis. Now, also in a production system, you'd probably be garbage collecting these, so you didn't have so many laying around. You can see that this is the default one, so if I send traffic to this model, it's going to actually go to that version. You'd want to update that on a daily basis, at least after you'd validated it. So, yeah. Any question? I forgot to say this. It was kind of difficult with all the interruptions we had. My preference was going to be to have questions in line, but I'm almost at the end of my talk now. But any questions about these pipelines or the training? Yeah.
The logging that you showed,
yep.
Is that something that's set out with the cloud box itself? Is that something if I add logging in my code that I could spit out to?
Yep. Yeah.
Both?
So if you do your print statements, your logging.info statements, if you're a Python programmer, those things show up here. And I think it tells you which one's which. Those, the standard error shows up as, unfortunately, as orange warning signs. Because there's nothing to be worried about. That's just XGBoost telling us that it's doing work. Any other questions? Okay, you guys have been very patient. So this is really the end of my talk. Just to summarize in a few points, productionization is hard, cloud is easy, and you pay for what you use on the cloud. All right, and a few teasers, I guess, before we move to see if there's any other questions about the entirety of the talk. But our team is working on increased focus on reducing MLF. So we saw probably 10 boxes on that page, and I addressed a few of them, like the continuous training case and the serving case, but there's actually a lot more boxes on there, and you better believe that we're spending time making this easier and easier as time goes on. Increased cost efficiencies. That's a continuous focus for us, because we're able to amortize the cost of the infrastructure across everybody, so we're actually able to get you lower costs than you might on your own. And then we're also working to allow data scientists like yourself, and even data engineers as well, to share their reusable work with others. We're working on ways to do that. So, any questions? Any other questions, I should say? Yes?
Yeah, you just brought up an interesting point about individuals. Right now I work with AWS or Paperspace, for instance, for the stuff I want to do.
Yep.
And then, of course, I'm the president of my team that go there. And that costs me 60 cents an hour, so that's out of my pocket, that's fine. Do you have any sort of facility here for the individual data scientist or engineer to do their experiments?
For the
individual.
I'm just trying to make sure I understand. What do you mean by for the individual?
For me. I want to set it up just for me because that's my experiments that I do on a Sunday and I want to show them to the team on Monday.
Yeah.
And right now I have to do that, for instance, like say on Paperspace.
And how is it? I apologize for my ignorance. What is Paperspace?
Paperspace is, I think, a competitor to AWS.
Mm-hmm.
It's 60 cents an hour versus 90 cents
I see.
But it works, as far as I can tell, if you have worked with them, they.
Is it like a Jupyter notebook?
No, it's just basically a VM. You
I see. Got it.
basically, you know,
Yeah,
you deploy your environment.
So when you show your work, you have a VM and what?
I would use Jupyter Notebook to show the work, yeah.
Got it.
Oh, yeah.
Got it. Okay. So I'm kind of a loose cannon, and this is being recorded, so I don't want to get fired for saying stuff I shouldn't about what's coming. I will say that we're working on making it very easy to get VMs that have Jupyter notebooks for doing that. The sharing that I'm talking about, I think even in your case, you'll probably find it useful, but unfortunately, that one I definitely will get fired for saying too much about.
Okay.
So hold on, I'm trying to remember if that's what the time frame is. Essentially, Google Cloud has, if you're not aware, a conference called Next, and I believe it's at the end of July. We'll have a lot of announcements there, maybe not everything that I'm hinting at here, but a lot of it. So you'll have to hold your horses until then.
So if I wanted to go out today and set up an individual account, that's not.
Oh yes, absolutely. Yeah, absolutely. You can do it on your own dime, absolutely. And we're trying, like I said, in very soon, I don't mind saying this, in the next couple of weeks, we'll make it very easy to get a VM for doing machine learning with a Jupyter notebook.
Okay.
Yeah.
Alright, do you have any tools for a non-technical user, like a graphical tools?
Yeah, fantastic. Are any of my UX researchers here? The researchers here, and the designers. So I hope I don't get in trouble for saying too much, or I don't think they'll mind. But yes, we have a whole team of UX researchers, UX designers, and unfortunately they're overworked, but we're focusing very heavily on improving the UX experience. I think you saw a screenshot. It might have been really hard to catch, but there was a screenshot where you just fill in a few parameters, hit click, and it will deploy your model. And that applies. We're working on ease of use for the training thing, where you saw a bunch of G-Cloud stuff that's like, why should I have to do that? Integrations with various products like Kaggle. And then I believe Ivoke, I think, is that how you say it? Yeah. She works with AutoML?
I'm looking for APIs.
Oh, the APIs, I see, okay. So if you haven't heard of AutoML, you essentially just upload your data, click a button, and it trains a model for you. Right now we have Vision, I think it's alpha, going to be beta soon. They're really focusing on the GUI there to make sure that's nice and slick. So all across the board, all the products we have to offer, including the ones you saw today, are going to see market improvements in the user interface in the coming quarters. Give it maybe 2 quarters or so because they are overworked. Yeah, good question. Any other questions?
I have a question. For example, I'm thinking of the current repositories that we work on. For example, we have the requirements file with all the dependencies. And I saw that, of course, in the Jupyter notebooks, you can specify the Python version that you want to run. But what about the other dependencies? Is something like a requirements file that we can add there?
Yeah, exactly. So particularly for training and even soon prediction, the current state of affairs is you use a setup.py, which you can put requires in it. It's kind of the same thing as requirement. Actually, I think you can literally include it requirements.txt. It's a little clunky because we don't support directly requirements.txt, but we are working on containers, which is at least I personally see it as the future way to encapsulate dependencies and things like that. We have considered from time to time directly including requirements.txt, so feedback like that, like, hey, why don't just let me submit my requirements.txt or something, that's good feedback, we'll take that into account. So, short answer, yes. Long answer, in various states of progress. Any other questions? Yes.
Actually, I'm working in hospital, so the most data that I deal with is patient stuff, patient information.
Yep.
I really like to use the cloud computing, but do you have any suggestion? Because my data cannot go out from the hospital.
So we actually are HIPAA certified for most of our services. Obviously, you can't just willy-nilly go take the data without your employer knowing, and probably needs contractual agreements and things like that. So be very careful about it. But the answer is yes. You can, clouds nowadays, in the beginning days, they weren't certified, and it was not a good idea. Well, it was probably even illegal for your data on the cloud, but that is no longer the case. So feel free to investigate through those channels what you can and can't do, and start using the cloud.
Do you want to speak to the people as an option?
Oh yeah, that's a good point too. So if at the end of the day you're not allowed to, or not allowed to yet, or whatever the case may be, Kubeflow, that I mentioned in the slides, will let you get started on your on-prem server on your laptop or whatever, and then if and when you can do stuff in the cloud, it's a seamless migration. Any other questions?
How do you access the Kubeflow? Do you create an account or?
Yeah, I've heard that that's a pain point actually. It's not too bad, but you go to cloud.google.com, it's probably going to tell you, I actually did it on my personal account for the first time the other day, and it's going to tell me that I get like $300 in free credit for the first year. I don't think it asks for a credit card, but I can't remember for sure if it does or not. It does ask for a credit card, but it doesn't charge.
After 1 year or something, your card reminds you.
It reminds you.
But it also asks for your permission before you make any trade. But
Yes.
if it's gonna get money from your account, you are getting an alert. So if you don't want, it just doesn't happen.
The third $301st, you get warned before you get charged that extra dollar. And so it's actually not too bad. It only took maybe less than 5 minutes, I think. I had a cloud account. And then especially for the ones that have GUIs, you can go do those, or if you want to use the samples and the notebooks and the quick starts to get going on that.
Just to segue to what Robbie was mentioning, since we've had a lot of action happening some time back, as a way to sort of make it up to you, if you want to get cloud credits, please reach out to me, and I will basically give you extra cloud credits.
For sticking around.
Oh, okay.
Do I get some too?
We'll figure it out.
Another question?
Yeah, I was going to ask about the charge structure. I'm doing this on the site in terms of GPUs and in terms of you charge by time or charge by.
Depends on the service. So the more infrastructure it is, the more it's like node hour cost. Like I have this VM that costs this much per hour of use, and it probably costs less